I don't know if there are any other questions before we go into this brief exercise. If you'd like to share any questions, please just enter in the chat window and we'll be doing another break. So there are no more questions for the moment.
So, about this time during the presentation on multi-layers, people's eyes glaze over like, I don't really believe all this stuff. And so I want to go through this exercise and hopefully by the end that you're a little bit more convinced maybe, a couple is a good idea. So let's just look at this. This is a 30-acre lentil field down by beach, satellite image, NDVI, Landsat, taken a number of years ago with the crop growing in July. So it's before the crop has started turning, but certainly it's covering the ground. And hopefully not many of you are colorblind in there, but the real bright red is the really productive areas, and as it shades down to darker colors, and certainly the blue and the black, those are really poor growing areas there. So I just want you to take a minute, think about that. Southwestern North Dakota, what do you think could be the reason why the productive areas are productive and the non-productive areas aren't? So just take a minute, think about it, give me some ideas, and I'll write them down as I see them.
So I could restate it as what could be reasons for the variability, maybe in the chat window?
Yep, that'll work. Okay, we've got drainage, moisture, topography, moisture, soil types. Anything else? These are all good guesses. Okay. Texture. Rainfall. High-low spots. Okay. Okay, well, let me give you a little bit more information. Here's one more. Water holding capacity. Yep. So this is what the topography of the field looks like, and I'll show both of them together so it makes a little bit more sense. So this, one of the things with Surfer is you can exaggerate the amount of relief that's in the field. I'll just tell you there's a 20-foot difference in about what? Well, it's about a 5% slope. There's about a 20-foot difference between the high part of the field and the base of this. So it's steep, but it's not that steep. You can certainly drive it with no problem at all. But this area around here is relatively flat, although I think you can see some differences in there too. So this is what the topography looks like. That's what the imagery looks like. So take a few minutes and tell me what's going on now. We got low yield on the slope. That's certainly true. And there's some moisture accumulating in the lower areas, so a little bit higher yield.
Yeah, and that.
Nutrient variation, deficiencies, toxicities in certain areas. Low yield on the washout area, some ponding maybe.
And then profundidad, so that's soil depth. I don't know if that translates well.
Yeah. It's like a soil type difference, water collecting in low spots, droughts, drought areas on the hilltop, higher yields in the good soils. Okay. All right. Let me give you one more piece of information here. Okay. This is the electrical conductivity for the map. The EC, this is apparent EC. It's not EC like you get in the lab, but it's relative EC. Goes from 4 to 28. This area in the southeast, really high. This area on the slope is really high. This area in the middle is fairly high. I mean, it's not as high as those, but it's fairly high. And then there's some areas that really, 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 really low up here in the tops. So let me show all three of them together. And that's roughly how they kind of lay. So looking at all that, now what do you think is causing some of that? Oh, yeah, the question is shallow or deep EC reading. These are shallow EC readings. So what does shallow mean? It just means shallow. It's not a particular depth. It varies from the soil you have, but certainly up in the upper rooting zone, these are where the readings are coming from. And frankly, in most of the fields I've looked at, the deep and EC are very much related. It's not always the case, but it certainly was the case in this field. They may have some pH issues. And salinity, soil texture. Anything else? And of course the drainage and the salt accumulation. Yep.
I have one in my chart window was a cation exchange capacity of soils from Sean.
Okay. Yeah, and there was a question, is sodium a problem here? I would say no, not in this field, although, you know, it can be a problem in that area, but not in this particular field. For some of you, if you're from the Midwest, let's say, or a very well-drained area in the South, it's really hard for a lot of people to grasp the effects of the salts. So the EC map really, the NDVI and the topography map, it's clear, and a lot of you said it, that there's certainly some CEC differences between the soils up on that upper part of the field as opposed to the lower part. In the southwest part of our state, we have residual soils, so we have some soils that are old sandstones over siltstones or siltstones over sandstones. And so even in the same field, there can be two different parent materials here, and I think that's what's going on here. That's why, and on some of this, especially the part that was eroded, the ECs are very low and the production is very low. All these areas here that are bluish and blackish on the sides of the slopes are probably very eroded. You know, this has been in no-till for probably 20 years. It still hasn't built up to really productive levels yet. It just takes a huge amount of time. But the EC explains a lot of what's going on down here in the bottom. The southeast corner, very much really high salt. Not so much sodium, but just really high salt. The drainage is pretty poor. There's a road ditch that goes on here. There's an elevated fence that's kind of humped up with soil that blew in, I suppose, you know, before the person went no-till. So it restricts the water movement across the field when they do have big rains. And then this area up here evidently has a fairly low, high water table because the salts are higher on that area of the field. This area here, the water table must be a little bit lower, and so the salts aren't expressed as much. But without having all three of these pieces of information, you really don't know which direction to go on it, and so that's one reason why I think that multiple layers are important. You just get more information out of the field, patterns make more sense. So hopefully that was helpful to you. This is that same field we just looked at. Here's the ridge line. This is the area of low productivity. So this area of lightness, I guess, or greenness, light greenness, are the low productivity areas. The areas that have the darker colors tend to be the more productive areas. So what, 1, 2, 3 different zone patterns. You can probably lump some of those together because they're so small. But when you layer the information, here the elevation, we used a watershed model, and we used satellite imagery, and we used EC. So you get one map with all the patterns in it.